Hello students, previously Form 3, Topic 2, Lesson 17, we are dealing with the volumetric analysis. We have seen the types of titration. The types of titrations were three. The first one was direct titration, back titration, and the third one was redox titration. So today, Lesson 18, we are going to start with the first titration, that's direct titration. So we are saying this is a type of titration that involves the addition of a standard solution to a fixed volume of the analyte with the aim of determining A, the unknown concentration of the analyte, B, the unknown volume of the analyte, C, the unknown mass of the analyte in a given volume of solution, D, the molar mass of the analyte, E, the percentage composition of the analyte, F, the percentage purity of the analyte, and lastly G, the water of crystallization of the analyte. Remember, when we are dealing with titration, we have seen some terms. One of them was a standard solution, and we say standard solution is a solution whose concentration is known. And we are having analyte. We said analyte is the solution whose concentration is unknown. Okay, direct titration has aims. These are the aims from A, B, C, D, E, F, G. So each of these aims, we are going to see it in details. So we go with general steps or the general procedures of solving direct titration questions or general steps of calculating direct titration questions. So the first one, you are supposed to calculate the molarity of the standard solution if concentration is given in gram per liter or gram per decimeter cube by using the formula molarity, which is equal to concentration in gram per liter over the RFM. So in case the molarity is given, that means you leave this first procedure, you start your working on calculating the number of moles of the standard solution by using the formula. Moles is given by molarity, because in our case, we said if you are given the molarity, you skip this procedure. Molarity times volume used over 1000 will be the formula that you are going to use to calculate the number of moles. Then the next step after that will be writing the balanced chemical equation for the reaction between the standard solution and the analyte. Thereafter, when you write the chemical equation, balanced chemical equation, the next step will be using the mole ratios between the standard solution and the analyte using the reaction that you have written, calculate the number of moles or determine the number of moles of the analyte. Then finally, from your 5, you have to use the number of moles of the analyte obtained above to determine the aim of the question. To determine if you are dealing with the first aim, that's the unknown concentration of the analyte or the unknown volume of the analyte or the unknown mass of the analyte in a given volume of solution or the molar mass of the analyte or the percentage composition of the analyte or the percentage purity of the analyte or the water of crystallization of the analyte. This is the general steps of solving or calculating direct titration questions. So we go to the first aim, that is determining the unknown concentration of the analyte. Remember, when we are dealing with molar solutions, we said concentration is expressed in two ways. One way was gram per liter. The second way was mole per liter or mole per decimeter cube. So remember, we said again, mole per decimeter cube, we mean molarity of the solution. Concentration in mole per liter or concentration in mole per decimeter cube is the same as the molarity of a solution. Okay, we got examples. 20 centimeter cube of a solution containing 4.0 gram of 4.0 gram per liter of sodium hydroxide was neutralized by 8.0 centimeter cube of dilute sulfuric acid. Full stop. We are told determine the molarity of the sulfuric acid. In bracket, we are given Na, that's sodium, which is the Rm23. Oxygen, it is relative atomic mass is 16. and the relative atomic mass of hydrogen is 1.0. So we are told determine the molarity. So in our case, we are given two solutions. One of them is sodium hydroxide and the other one is dilute sulfuric acid. So let us see which one is the standard solution. Because the first procedure, we are told calculate the molarity of the standard solution if concentration is given in gram per liter by using molarity equal to concentration in gram per liter over the RFM. So in our case, the standard solution will be sodium hydroxide because its molarity is known. Here you are given concentration in gram per liter, so you can get this molarity. But sulfuric acid, you are given only the volume. So that means its concentration is unknown. Or in other words, sodium hydroxide is a standard solution because we know the concentration. The concentration of this sodium hydroxide is 4.0 gram per liter. Because say concentration is expressed in two ways. One way gram per liter, the other way mole per liter or mole per decimeter cube. So in our case, sodium hydroxide is the standard solution and sulfuric acid is the analyte. Okay, what was the general procedure of calculating direct titration? The first procedure was calculate the molarity if concentration in gram per liter is given. So using the formula, molarity equal to concentration in gram per liter over the RFM. So I have to start first of all getting the RFM of sodium hydroxide. RFM of sodium hydroxide. So what is the RM of sodium? 23. Then for oxygen 16 plus 1 for hydrogen. Here we are going to get 40. So next, using the formula molarity is given by concentration in gram per liter over the RFM. So in our case, concentration in gram per liter is given 4.0. It's given 4.0 gram per liter. So we write 4.0 divided by the RFM of sodium hydroxide, which is 40. In our case here, we are going to get 0.1 mole. That's the first step. The second step, you're supposed to look the number of moles of the standard solution. So how do you get moles? Moles is given by molarity times volume used over 1000. So we write moles of sodium hydroxide. It is given by the formula molarity times volume used over 1000. So this means our molarity is 0.1 times our volume of sodium hydroxide is 20 centimeter cube, then divided by 1000. So here we are going to get 0.002 moles of sodium hydroxide. That will be the number of moles of sodium hydroxide. Okay, next step, you are supposed to write the reaction, the balanced chemical equation or chemical reaction between the standard solution and the analyte. So the standard solution here is sodium hydroxide, and that analyte was sulfuric acid. So sodium hydroxide is aqueous, sulfuric acid is aqueous. When they react, we are going to get sodium sulfate, aqueous, plus we are going to get water, which is liquid. So we are supposed to balance the equation. So we are going to put 2 on the side of sodium hydroxide and 2 on the side of water to balance the equation. So thereafter, let's get now the number of moles of the analyte, that's sulfuric acid, using mole ratio. So what is the mole ratio between sodium hydroxide ratio sulfuric acid? So here we have 2 in the side of sodium hydroxide and we have 1 hidden on the side of sulfuric acid. So here we have gotten the number of moles of the sodium hydroxide. So we are going to write, if we know the number of moles of sodium hydroxide, which is 0.002 moles, what about the one for sulfuric acid? We cross multiply. There we are going to say 0.002 times 1 divided by 2. So here we are going to get 0.001 moles of sulfuric acid. Okay, after that, the next procedure was you are supposed to use the number of moles of the analyte obtained in from year 4 here to determine, to calculate the aim of the question. And the aim of this question was the molarity of the sulfuric acid. So what is the formula for calculating molarity Molarity is given by here I have moles. If I have moles, I can multiply by 1000, then again divide by volume used. Volume used. This is the formula for calculating molarity. So in this question, we have the moles of sulfuric acid to be 0.00001 moles. We have the 1000 in the formula, and the volume used here will be 8.0 because the volume of the sulfuric acid or the volume of the analyte is given. So this will be equal to 0.001 times 1000 divided by 8.0. So here we are going to get 0.125 mole as our molarity. Okay, that's the end of that question. We are going to go to question number 2. So question number 2, we are told 20 centimeter cube of diabacic acid H2A required 25 centimeter cube of 0.2 mole sodium hydroxide for complete neutralization. So the question part A, we are told calculate the number of moles of the sodium hydroxide used. So here I have diabacic acid and I have sodium hydroxide. So the molarity of sodium hydroxide is given, or the concentration of sodium hydroxide is given, and its volume is given. So that means sodium hydroxide is the standard solution here, and the diabacic acid is the analyte. So if we are dealing with the number of moles of sodium hydroxide, we can get it using the formula. So number of moles or moles is given by molarity times volume used over 1000. So in our case, the molarity of sodium hydroxide is 0.2. It is here 0.2 times the volume used is 25 centimeter cube divided by 1000. So here the number of moles will be 0.05 moles of sodium hydroxide. That's part A of the question. So next, part B, we are told the molarity of the diabacic acid. The molarity of the diabacic acid. So if we need the molarity of the diabacic acid, the steps were, I have to get first of all the number of moles of the sodium hydroxide I've gotten here. The next step, I have to write the reaction between the standard solution and the analyte. So the standard solution here is sodium hydroxide solution. So sodium hydroxide solution reacting with the diabacic acid H2A aqueous, we are going to get Na2A aqueous, then I'm going to get water, which is liquid. So to balance the question, we are going to put 2 here, we are going to put 2 there. So let us see now the number of moles, I mean the mole ratio between the sodium hydroxide and also the diabacic acid. The mole ratio will be 2:1. The 2 is here and that one is hidden here. So if I have the number of moles of sodium hydroxide to be 0.05, what about the number of moles of the diabacic acid? So it will be 0.05 times 1 divided by 2. This will be 0.025 moles of the diabacic acid. So if we have the number of moles of the diabacic acid, we can get the molarity, because molarity is given by moles times 1000 over volume used. So the number of moles is 0.025 times 1000, which is in the formula, divided by the volume used of the diabacic acid. The volume used of diabacic acid is 20. So we are having divided by 20. So here we are going to get 1.25 mole. That is the molarity of the diabacic acid. That's the end of our question. Learners, you have to know, out of the 3 titrations, direct titration is the mother of titration. So you have to know all the aims of that direct titration, their calculations. That's the end.